Okay, so this is week 4 WebAssign assignment. It's similar to the problems out of the textbook, but I will show you how to do this one in particular. So here's a version of it. And I'm going to select, I have to calculate, what do I have to calculate? I have to calculate R and the regression equation and then do a prediction. So I'm going to show you how to do this with a spreadsheet today. There are many applets. You can use a graphing calculator if you have that, but a spreadsheet's free and it's here. So I selected to go back to this. So I highlighted these numbers. So I highlighted the data table with my mouse. I pressed Control-C to copy it into my clipboard memory. And then I went to my spreadsheet and I Control-V to paste it in. And notice that it nicely pasted all into one sheet. Again, you've heard me say this before. If you double click on a cell and try to paste it in, it'll all be put in one cell, and that's not what we need. We want them in the separate cell. So just click once, and then it's fine. So then we have some things to do. We have to calculate the correlation. Do we have a picture of this graph? I mean, do we have a picture of this data set already? So I'm seeing a fairly strong linear association with this data. So I suspect the correlation is going to be fairly strong also, fairly positive, high positive, close to 1. So let's come back to my spreadsheet. And the way you can get a spreadsheet to do this, I mean, there's many ways. I'll show you a couple while I've got time here. So I'm going to tell me this is the correlation. That's for me as a human. Of course, it'd be nice if I spell it right. Correlation. Should be an A in here, right? Yeah. So then equals, the way you get a spreadsheet to do a formula, do equals. And I'm going to start typing the word correlation, and you see how it pops right up there. And then you want to do the Y values first. And then you want to do the X values, as if I didn't get those all. I'm going to tweak that and make it be 3. For some reason, I didn't like when it clicked. Then I'm going to do the X values. And I'll press enter, and there's the correlation, fairly high like I thought. The coefficient of determination, the R squared if you want. I don't remember if we need that, but let's calculate it. So I'm going to just square that last number. So equals, I'm going to click on that cell, caret 2. And then if they want it as a percentage, and often we do, we'll times it by 100. So R squared is about 84%. So 84% of the change in the amount, the supply, is caused by a change in the price. Now I need to do the slope. I need to do my regression equation. There's a lot of ways to do this. One way that's really slick is have it just to calculate the slope. Equals slope, and it comes right up. And again, they're looking for the Y values first, comma, the X value second. If you do those reversed, it'll give you a number, but it'll be an equation predicts what X based on Y. And then we need to do the Y-intercept. And that equals intercept, just like you probably thought I was going to say. The intercept, there we go. And again, Y's first, comma, X's. Okay, so that gives me the numbers, and that would work for the formula. One thing I want you to keep in mind, one thing I'm going to be looking for, is that you know how to interpret what's going on here. So one way to do that is to actually write out, instead of Y equals MX plus B, supply. And often some other textbooks, this is a predicted value, so they put a little hat symbol over the supply, over the Y output. And then we're going to write, let's see, what's the slope? 119.21 times the price. Notice I'm not using X and Y. And price isn't predicted. Price is an actual value. So that's why we don't need a hat on it. Minus 112.3. That's all I'm going to use here. But there's my least squares regression equation in context of the problems. I encourage you to do this. Write them this way when you're doing paperwork. And then I think the last question, let's see, there was one other part to this question. So there's R, you can skip the significant thing. Is it significant? Let's see. I'd have to do 12 data sets. Let's see, where's my Stevens book? You do not have to do this for this week because you don't know what, you haven't done any statistical testing yet, so that wouldn't make sense, but I will do this. It basically deals with, this is a sample of 12 years or 12 prices, and you got to determine whether that's statistically different from any other year or from zero, or if the correlation, that's what we're doing. We're trying to test to see if the correlation is far enough away from zero to say, yeah, there's a fairly strong linear correlation here. Let's see, I had 12 values, right? We don't subtract one from this, no. So I had 12 data values. This says my correlation is you probably can't see that. Whoops, no. I want to zoom in. How do I use this software to zoom in? Need to get this out of the way. Tables. No, I don't want to think I want to go zoom that, but here we go. 12. I had 12 data points. If my correlation's higher than 0.576, I can say that it's statistically different. So that's what you do. You look, you sample how many data pairs you have, and if your correlation's higher than that, you can say, yeah, it's statistically different from zero. And that doesn't mean much to you right now, but it will. So let's see. And then what's the last part they want us to do in this? Where's my WebAssign work? Then we need to do a prediction. So what you're going to do is you can drop it in. You're going to substitute in 5 for your equation. So if I go back to my board here, I can get my equation by saying 119.21 times $5 minus 112.3, and I'll get a value, whatever that value is. But since I'm here and I've got the spreadsheet open, I can also say predicted for 5, prediction for $5. And what I'm going to do is I'm going to take the slope equals, click on the slope, times it by 5. I could actually set up a formula so I could change the value, plus the y-intercept. Okay, and that's going to be the predicted value. So that predicts this. The data suggests that when the price is $5, the cost or the supply will be 483.7 units. Notice it's a little off from what the actual data is. That gets into residuals, which that isn't what this problem is asking us about, so I won't get into that. But that's how you use a spreadsheet to do this. You don't need a graphing calculator. And there's applets that'll do this too if you want to explore those. Anyways, I'll stop this video.